Okay, hi everyone. Another design review, this time about calculus and algebra. And I think we already discussed a bunch of the material up here, correct?
Yes.
Yes, that's
I
done.
don't
You
think we need
might
to.
want another view on typesetting because that's ongoing.
Okay.
Did you want to what do you want to bring up, Itai, there?
Right.
That's,
What's new since last time?
Oh, that's exciting. Look at that.
what
Yep.
is that?
Look right, but
That's
it's
percent modernization. So if
Oh,
you select that, you'll get a reference to that cell. Oh, there's some that it's working for me in the latest build. So maybe there
okay,
was some.
okay. But by the way, could you make a comment to somebody that really doesn't look right? That really isn't right. That the
Well,
appearance
we
is
we we
definitely
have a dedicated review for this on
okay.
Tuesday. So let's
Okay,
just
okay,
have that
fine.
conversation
Fine,
then.
fine. Okay.
Right. So symbolic delta product array has new typesetting since last time. So give it like a list 2, 3, 4, and then a list of list 1, 2.
Like that.
Yep. Right. So it has dimensions 2, 3, 4, and we're identifying dimensions 1 and 2.
You know, this is going to be relevant to the whole string diagram generalized tensor thing.
Yes, it's right. It's another form of connecting in indices.
Well, I'm happy that this has an utterly obscure name.
Yes, and right. I can't say I'm super pleased with that appearance, but the the for whoa. I wonder how that happened. Okay, I'll need to look into that.
The message
Fairly
seems to
amusing
be
claim. What's that?
the message seems to be not coming from the newest version of the error messages.
Okay,
So,
I'll that's a bug I'll have to hunt down.
so
I,
you need to add one dimension for it to be valid, and the error message is wrong, of course.
Okay, fine.
yeah. So if you added a 5 there, then
I have no opinion. I don't really know what this means.
okay.
I mean, I do know what it means. It means you're identifying 1 and 2 and 3 and 4, but the 2, 3, 4, 5 at the bottom.
Right. That's sort of like right. So just like one's array of list 3, 4 gives you a 1 with 3, 4. I mean, there it's a. I suppose we could change it from an underscript and an overscript to a sub superscript to be more like the others. It'll use up a bit more space that way, but
Thinking. Hold on a second. I mean, when you see a product, usually the thing at the bottom is I equals 1 to whatever it is, right?
right.
Which is kind of defining the dimensions. I suppose you could think of it in some way.
Exactly.
Are you sure we even want a notation for this? Or is the notation so obscure we might as well just say symbolic delta product array?
Well, Adam, do you have an opinion on that?
I think we need the notation just to make the outputs compact. This thing will get produced by derivative. So
can you show me an example?
Derivative of total. So you need to array symbol or symbol some array some name like you need to put the and then 2 3 4 comma 2 3 4 or something.
Yep. And then differentiate that with respect to the array.
With respect to the array, yeah.
with respect to that whole array.
Yep.
Yeah.
And it'll be chaining itself like crazy. No? That's pretty weird. That's pretty weird. The fact that it's a product is usually kind of a
Symbol.
thing that says do this. It's an operation.
It's an
It's not
operator,
like a ones array.
Oh,
for
well,
example.
right. Well, I mean, right. One way to, yeah, right. I mean, it is a product. Right. The concrete form of that symbolic array is a table of timeses of deltas.
I'm not buying this. I mean, to me, this is a generalization of the I, of the identity array in some way.
Mm-hmm.
And I don't understand this one. What the heck is the difference between this I 678 and the 1 6? I mean, this is incredibly obscure. What we see.
Well, I is an identity array and 1 is an array of ones.
Okay, fine. But then this is another array that's like an identity array or this array or that array. It's not a product symbol, which is kind of like a do this type operation. You see what I'm saying? If we're
Right.
going to do this, here's what I think we should do. I think this thing should look like one of these, but instead of being a great big pie, it could be, if you really want it to be a product thing. I mean, I think it's more like, you could make it an idealized stripped pie or something. Do we have one of those?
We should have script Greek letters. Yeah.
We don't appear to have that.
We had, maybe we added the formal Greek letters.
Okay. Well, what I recommend is a stylized pie with similar kinds of, if this is 6, 7, 8, what is this? Is this 7 times 8 times whatever it is?
Yeah.
Okay, so then use that same notation. In other words, instead of an I there, we need something, given that we're calling it product array, we can use, some kind of italicized, stylized pie thing, but then subscript it like that. And then I would just say, put 1, 4, either space or semicolon, 2, 5. Don't put another Greek letter there. You see what I'm saying?
Okay. We might want to then use like a capital delta or something rather.
Well, except we called it
it's a delta product. Okay.
Yeah, setting, yeah.
Okay. Right. And the other issue is the string character.
Just a second. I need to ask Roger something. Roger, do you have to leave at the top of the hour?
I do, yeah.
Okay. All right. Sorry, say that again. Whoever was saying, what is this creature here?
Yeah.
Right. That is your idea, right, of an array with the rank over it. Right. So that 3 is standing in for the arrow or double arrow of a vector or matrix.
Oh, right. But although this rank is now down as a subscript. And what the hell
that is not the rank. And there's a reason, right? I mean,
that's not the rank. That's right. That's the dimensions, not the rank.
Well, that's half of the dimensions, which is why I used a different letter. So on the ones array, those are the dimensions. On the identity array, those are half of the dimensions.
Boy. Shouldn't the ones array be 6 times 7 times 8 down here? What?
Well, I mean, so what do you think the rank of the ones array is?
It's got a bunch of ones going down the leading diagonal. So I think it's a 6 by 7 by 8 object. Am I wrong?
You are correct. What do you think is do you think the dimensions of the identity array are?
Hold on.
Tensor dimensions.
Well, why did that happen? Oh, tensor dimensions.
Mhm.
Look at the square.
What do you think the dimensions of that are?
Wait a minute. Let me think for a second. I see. Each one is one side. So it's the doubled version of that.
Mm-hmm.
So it's like it's a 2 by 2, and the 2 identity matrix is a 2 by 2 matrix.
Yes.
Yep.
Exactly.
So this, I suspect, is going to be 6, 6, 7, 7, 8, 8.
6, 7, 8, 7, 8.
Yes.
Oh, okay. Roger, do you have a comment on this?
On the notation?
Yes.
Yeah, I like the 1 and the 0 for the ones array and the zeros array.
Yeah, I
the
know. I put the subscripts.
And the identity, that's also good. But in terms of
how to do the subscripting, given that one of them is the literal. See, I mean, this looks like those are array elements.
Yeah.
Which I don't like. And I think that the times here would be a nice way of indicating dimensions. The problem here is that those dimensions are, look, I've got a different suggestion. On the I, to use the timeses here, and on the I, to use 6 times 7 times 8 times, and then some symbol after that to indicate that it goes on.
Okay.
Does that make sense? I mean, and then we can use the same thing for the pi. We can use the 6 times 7 times 8 there, and then the superscript can be the 1 4 semicolon or something 2 5, and then that would be times, and then some little. You could have a dot dot dot, or you could have some kind of. Actually, the other thing you could do. This is a better idea.
Is there a symbol that means repeat?
Well, dot dot means repeat for us, but it doesn't mean. But it means repeat any number of times. My better suggestion is to just put the 6 times 7 times 8 in parentheses.
Okay.
And then for the pi, for the scripty pi, whatever that symbol ends up being, yeah, it's nice. Symbolic identity array is nice. Symbolic ones array is perfectly nice too. This symbolic delta product array is really funky, but that's okay. Okay. By the way, if I say array dot here,
that needs 2 things.
I know.
Okay.
So would that be 8, 11 or something like that?
Yep.
And
then you'll need a comma 1.
Comma 1, yeah.
Or 2.
Where's the comma 1?
2, then it has to be 8, 7, 8 or something, so that you could.
Yeah, 7. If you do 7, 8 there, they'll match up with the last 2 dimensions of the first one.
Yeah,
yep.
Like that.
And
now you need
comma 2.
No, I need a comma 2.
Yep.
Level specification. So you need to, well, whatever. One argument?
Did you?
Oh, I closed that there.
Okay.
Array dot, and then close the total. Oh boy, that's pretty exotic. And that's a transpose in direction 3, right?
Right. It's
rotation by 3.
Rotation by 3.
What do you mean by 3?
the dimensions get rotated by 3 to the
Oh, I see,
left
I see.
or right.
This is pretty cool, actually. This is really symbolic tensors.
Yes,
Cool.
it's actually very, very nice to make examples from this.
I mean,
Very cool. Now we just need string diagrams and we'll be all set.
Right. The one other thing is the string characters and input cells. So if you copy that A, say, into an input cell, or the whole expression into an input cell. Right. So you see how it shows the quotes. And I looked into this.
But what about the purpling?
That
is a bug.
That is a bug that I'm not sure. I will have to investigate that if this notebook can be sent to me.
What is transpose 2?
It's it's 2-argument transpose. That's just a missing text resource. I'll fix that.
Okay.
That
little 2 up there is, oh, that's a transpose. Wow, something went very, very haywire here.
No. That's you're inside of the transpose, but it's not a transpose.
That's a square.
No.
That's 3. Yes, it is. It's 3x squared. Because
Right.
I did a cube. Right.
Right. So that
blah, blah,
there's
blah.
a square. It's not a transpose.
No, okay, fine. I understand. But this thing here, I don't understand the tensors. I don't understand this. Array dot of this is a tensor here, right?
Yep.
Then that's a tensor. But what's the operator between that tensor and this tensor?
Multiplication times.
Right. So this is really symbolic arrays, not symbolic tensors, because we're allowed non-tensorial operations like component-wise multiplication.
And that 2, should it have had a parenthesis here? Or is that right? No, that's right. That's right.
That's right. It's just on the A.
Okay, so your complaint, I mean, so we need to find the bug here, but the issue is these string characters.
Right. And so basically, I can't turn them off and maintain any editability. I mean, I had a conversation with John, and well, I first played with it and I discovered I could very easily corrupt the input in ways that only made sense because I had access to the source code of the front end.
But what about template box and things? Why can't you use that just for the A itself?
Well, I don't know what you mean.
Why can't you wrap an interpretation box around this quotes A? So that
well, I mean, so there is the solution of completely turning off editability.
No, I understand that, but I'm suggesting turning off editability specifically for the A on its own, to have a blob of uneditability. So the A, if you wanted to change that A by typing over the A, you couldn't do it, but you could remove the A altogether and put something different in there. I'm suggesting a local lump of non-editability.
I
think you can do that with an interpretation box or template box. Why don't you look at it? I think it's not so.
I mean, I can turn off editability of right. I can turn off editability of the A, but I don't know that I can turn it off and still and still maintain any way of replacing it.
No, but I think you can just mouse over the whole thing. You can just select the whole thing and zap it. Even though the thing itself is not editable inside, you can take the whole object and zap it. See what I'm saying? Just try it. I'm pretty sure I'm right about this. Look, you just put.
I'm pretty sure I will try it, but I'm pretty sure you're wrong about it. Yeah.
Okay. Look, interpretation. What is it? A, B, or something. Okay. Now, if I then take this. Okay. So look, if I make a table of these things. Okay. Now I try and edit the A. I can't do it. It beeps, right?
Mm-hmm.
And if I evaluate this, it'll turn into a bunch of B's. Okay, I can't edit the A. However, I can delete the A and turn it into a U.
Right, but that's because that's the complete expression. The A by itself is not the complete expression, right? It's the A with the overscript 3 and all the others and the tooltip. That's the complete expression. So you could blow away the entire symbolic array, but you couldn't rename it from A to B.
No, look. I'm claiming it's this. Okay? Now, here, if I try and edit the 7, I can edit it to 9. Okay?
Right, because that's a separate expression. Right?
Well, why isn't this a separate expression?
Because that's all part of the symbolic array. That whole thing is the symbolic array.
All right. Then what I'm saying is just make the whole symbolic array uneditable.
Okay.
That's what I would do.
Okay.
I don't think it's that big a deal because I think recreating that thing with editing is such a frigging mess anyway. You're going to need to respecify it symbolically.
Right. Well, I mean, it means you wouldn't be able to, change V to a V sub 1 or something.
I think that's okay.
So
I think
it's
fine.
going through input form. But
yeah, it's fine for now.
Yeah.
Okay.
Okay, what's this? Conjugate transpose. Wait a minute. What's that?
That's the same thing as transpose.
Oh,
But
it's
it has
just
a cycles argument.
Yeah.
because it's just a different notation for permutation. So it just eats more permutation. It was a
I
list.
understand.
So it's just this pure addition.
Wait a minute. What's tensor product?
An outer product.
Okay.
Right. It's the tensor product that understands, assumed arrays.
This is a wild animal. Look at this creature. It's cool. Really cool. I should have looked at these before. Huh. Okay. Now, I don't understand why you're not subscripting with P times, P cross Q cross R here.
Because
Because you don't care, because it doesn't matter.
I mean, I did originally, and everybody hated that.
Okay, fine. Well, why are you subscripting this?
Because that is a particular.
It's a constant.
Right?
Yeah. Okay. So the argument is this: if I've got a thing called A, I always intend it to have a fixed set of dimensions.
Yes, at definition.
Well, except that I could perfectly well, in this formula here, I could have messed this up by saying, PQZ.
Yeah, but
and then what the heck is going on there?
But that's got to be something different. I don't know what's going on there.
That seems wrong.
Adam,
I think this is
trying to
where
understand
Adam
what
is
was.
assuming that things that are not explicitly different are equal to each other. And and remember, I was opposed to that, and you're like, oh well, if Adam thinks it's okay, but that's the consequence.
Yeah.
Is that the partial derivative issue? That thing is no longer dependent?
No, the other thing, the other array symbol A is a different thing. So the first A is different than the second A.
Yeah, that's right.
You gave the same looking name to two different things.
But so what? I mean, so.
So Stephen, do the following: copy out those two different A's and put a plus between them.
And it's going to look very weird. It's going to say A plus A.
Oh, it does.
It does.
Okay.
Yeah, there are different things.
And so clearly, if I same queue those things.
Well, that's true. But all right.
So,
but on the other hand, if you do something like tensor dimensions on %21.
Yeah. So tensor dimensions will tolerate this thing.
What the heck? Why does it do that?
Well, that's the only possibility that I think makes sense. Otherwise, it doesn't make sense. If z is not equal r, then the thing is not valid. So if you say tensor dimension generate condition goes to true, then it will give you the conditions.
I see.
But also, I don't think that this is how people would type it. I mean, a bunch of array symbols in a formula. I think I would find A equals some array symbol, and then I will use my A.
Yes.
Yeah, I agree. Right. Okay. I mean, we got to get some more, we should tag these things as experimental in this version. We should get a bit more experience with them.
Yeah.
But I think this is going to be lovely.
Yeah.
And I feel like just sending a screenshot of this to the folks I was talking to recently who really wanted this functionality.
I think it's a little bit weird that those, like example 4 and 5 there, work without a list around the vector symbol in the second argument, right? Normally when you're doing a gradient, right, it's list of list. And here we have a vector symbol.
But a vector symbol is a list implicitly.
Right, but where's the list of list is what I'm saying, right? A list normally means something else.
I'm confused.
Yeah.
Why isn't this?
I think what Itai is referring to, that when we introduced array derivatives in version 5, we had to add another level of list because you had an explicit list.
Compare D of f of xy, list x2, and then D of f of xy list of xy.
Another brace. You see, that was the only way to.
I don't think that's a problem because this is now an implicit vector.
Yeah.
Whereas this was an explicit vector.
Exactly. I don't think it's a problem either.
Okay.
Okay. Yeah, this is lovely. We should have done this years ago. We just didn't know how to do it.
Exactly. We actually derived a new chain rule. The array chain rule.
Cool. Yeah, it's really nice. Okay, we've just got a few minutes here.
We're gonna have to probably, well, let's see what you have to say.
Yeah. Let's just get some sense of this. It's interesting here that unlike an equation solution, you're just giving the values. This is like d stationary points values type thing.
Yes. They are that. These point values, point coordinates maybe.
I mean, it might be better to call it d stationary point values. I agree.
Or just stationary values.
Yeah, why not?
Is there an R equivalent?
Is there a what?
Is there a, is there a...
Well, what happens in the multivariate case is the issue.
I'm sure there are examples.
You'll get lists, yeah. If you scroll and find system examples over there. Yeah. Maybe.
The heck is this?
This says that the stationary point 2 is stable. The stationary point 3 is not stable. It's unstable.
We're going to have more of a discussion about this.
Mm-hmm.
That's a very weird setup. I mean, I understand what you're doing there, but I mean, to me,
so often
it almost
what can
seems like
happen,
it should be an association that's returned.
We tried it early on, so we can go back to it if required.
No, I mean, maybe it's wrong, but it's just that these things where sort of the return value is kind of an encrypted, enlisted thing. You know,
we can very well discuss sort of what the correct return value, form is.
Yeah.
Why is that font size too big? I'm sorry.
Oh, no, it's just copied from the documentation, that's all.
I see. Well,
yeah,
that's a problem too, that it didn't.
That's a first order system now. Next one. Non-linear system, sorry. So again, you could
really cool.
Yeah, but yeah. It's been highly well tested. I mean, with lots and lots of references, like all the major.
One thing that often is there are parameters, and we're able to actually give conditions on parameters for stability.
I understand, which is really interesting.
Which is interesting, yeah. The other thing is sort of the discrete one, the R stability one, is relevant.
Okay, but hold on. In this case here, I don't like D stability. I mean, what you're giving here is the point and its stability condition.
Yeah.
Yes.
So it's local
wouldn't it be
stability
more D
conditions.
Stability conditions?
I mean, so when there are no parameters, there is. I mean, it's just true false, right?
That's fine.
And otherwise, it could be stability conditions. It's
because I mean, if I see this, if I saw D stability conditions, I see the result is a half true. I've got a fighting chance of knowing what the heck that is. If I just see D stability, I have no clue what that true means.
Yeah, it's fine to change, but it's a bit like some convergence
flag from a Fortran program or something.
No, I mean, stability conditions is not. It's not a horrible name. It's a pretty good name. I think.
Yeah. Okay. So that would be. Okay, so it would be D stationary values.
Stability like classification.
Sort of what?
Isn't it more D stability classification than conditions? Right. I see.
No, we don't really classify in different kinds of stability. This is all asymptotic stability.
Right, but you're giving true and false, right? Are there possible conditions other than true and false in the
yes, if the parameter, you can just drop
the parameters, you get the logical formula.
And but also right. I mean, there's sort of a saddle pointy type thing where it's kind of stable in one direction, unstable in the other. What do you give here?
Then it's not stable.
Unstable. It's not asymptotic stable.
Then it's not. Yeah, exactly.
That's the oscillatory case.
Classic pendulum.
Yeah. That's cool. What the heck is this?
This is a recurrence. So it's a difference equation.
Stability. What is stability for a recurrence? It's whether.
So a stationary point is first thing. Okay. So stationary point means that the next point is the same as the previous one. Okay. If you use differences, it will look exactly the same as the derivative stability, right? Because then the difference on the left-hand side. Yeah. Okay. And stability means exactly the same as for differential, in the derivatives, that asymptotically the solution goes to that point when it's close, when it starts close enough.
Yes.
So that's a typical cobweb plot kind of picture.
Yes. Well, this is lovely. I think, though, we're going to need another meeting.
I think so, too.
Yeah.
Okay. Maybe tomorrow, right?
Would be great.
Yeah, sure.
Yeah.
Can someone here who's a planner, scheduler, etc.?
Claudia?
Yes, I will.
Jessica?
Okay. Sounds good. Kristen is away for a while, so it will be different people who are scheduling. Okay, that's some very nice functionality. Really, I'm excited about that functionality. Although I want to really understand how it will dovetail with like string diagram type stuff. Do you think you understand that, Roger?
No, I don't. No, I need to read
I'm a
up.
little concerned about it because I'm concerned. There's a thing I just was looking at, these plex diagrams, which are yet a generalization of string diagrams that deal with the fact that, you know, when you have tensor contractions, they're like graphs where one index is, you know, Einstein summation convention with another index. Does that make sense?
I see. Yeah, it makes
But
sense.
a hypergraph, a plex is a hypergraph where in general you can have three indices or any number of indices all kind of running together.
I need to really get myself up to speed on that. Who is Nick?
Nick is Carlos also. I mean, we can look. I'm trying to learn. You know, I think there's a very elegant way of dealing with all these things.
Mm-hmm.
Very elegant, which will, you know, and I think we are going to be forced to have hypergraphs as a built-in thing, and we're getting an awful lot of functionality around them. So I don't think it's going to be too hard.
Mm-hmm.
But it's very elegant, very, very elegant.
Okay.
So, and by the way, it also segues into category theory and all kinds of other cool things.
Right.
So, okay. Good stuff. Talk to you all soon then.
Okay, thank you.
See you.